This week we're going to be solving systems of linear equations. A system of linear equations is a set of two or more linear equations containing two or more variables. A solution of a system of linear equations with two variables is an ordered pair that satisfies each equation in the system. So if an ordered pair is a solution, it will make both equations true. If an ordered pair does not satisfy the first equation of a system, there is no reason to check in the other equation because it has to make both of them true. Now, if we're going to solve a system of equations by graphing, it's very easy to do. All we do is we graph the two equations. Where the two lines cross, that is the solution to the system of equations. So in this problem, you can see that I've graphed the two lines out. The answer is the ordered pair 2, 3. Sometimes it's difficult to tell exactly where the lines cross when you solve by graphing. It is a good idea to confirm your answer by substituting it back into the equations. For example, in this last problem, 2, 3 is my solution, so I could check myself really easily just by plugging it in to the original equation. So my x value is 2, my y value is 3, so here I'd have 3 is equal to 2 times 2 minus 1. Well, 2 times 2 is 4, minus 1 is 3, so 3 is equal to 3. Yep, it works in that one. But remember, it has to work in both. So again, I'd put 3 here, negative 2 plus 5. Well, negative 2 plus 5 is 3, so 3 is equal to 3. Yep, it works here. So I just plugged it back in, and it makes both equations true, so that means it is an answer for the system of equations. So in order to solve a system of equations by graphing, we just graph the two problems. And let's review graphing. So y is equal to 1x minus 3. This is the y-intercept. This is the slope. So my y-intercept is negative 3, so I put a point there. My slope is 1, so that means I go up 1 over 1, up 1 over 1, up 1 over 1. I do this a bunch of times. Okay, and then my second equation, I usually do it in a different color, negative 1x minus 1. Okay, so I have negative 1 here, but this time I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and you can see right away that it's going to cross right here. It looks like it crosses at 1, negative 2. I can check myself just by plugging it in, and you'll see that it does work. So graphing a system of equations to find a solution, fairly easy to do. Just have to remember how to graph an equation. So here's a problem off our practice, which pretty embarrassed to put this problem on to practice, but it says the graph of the system of linear equations is shown below. What is the solution of the system? My goodness, they've already graphed it for us. So my answer is right there. What point is that? Over 2 up 4. So 2, 4 is my solution. Get that one wrong. Shame on you. All right. Another way of solving a system of equations is by using substitution. The steps for substitution are below. Step 1, solve for one variable in at least one equation, if necessary. Step 2, substitute the resulting expression into the other equation. Step 3, solve that equation to get the value of the first variable. Step 4, substitute that first variable into one of the equations to get your second equation, and then write your answer as an ordered pair. Here's an example. Y is equal to 2x, y is equal to x plus 5. Now, one of the equations has to be either y is equal to or x equals 2. Now, in this problem, they're both y is equal to. Awesome. Because substitution means we know y is equal to 2x. We know that. They tell us y equals 2x. So in the second equation where we see y, we substitute 2x into it. That's why it's called substitution. We're taking what we know y is equal to and substituting it into the other equation. So now I'd have 2x equals x plus 5. So that was step 1. The equations are already written as y is equal to. Step 2, I substituted in. Step 3, I'm going to solve for one of the variables. So I'm going to just subtract 1x off of here. So I end up with 1x equals 5. So now I have one of the variables, x equals 5. Now I have to substitute this back in to my original equation, y is equal to 2x. Again, I'm substituting the 5 in for x. Substitution. So y is equal to 2 times 5, which is y is equal to 10. So my answer is 5, 10. Done. That is substitution. Most of us have used substitution forever because it's much easier than graphing functions out. All right, let's try another one. Solve by substitution. Step 1. Is one of the equations written as x equals or y is equal to? Yes, this one is. So I know what y is equal to. It equals x minus 4. So I'm going to substitute that back into the other equation. So now I have 2x plus x minus 4 equals 5. Solve this equation for x. So 3x minus 4 equals 5. Add the 4 over, so 3x equals 9. X equals 3. Boom. I know what x equals. So let's figure out what y is equal to. So I put 3 here. 3 minus 4 is -1. So y is -1. Once you have one of the variables, it's really easy to get the second variable. Okay, now this problem here, neither of the equations is set to x equals or y is equal to. So I'm going to rewrite this. I'm going to subtract the y off of this side. So I'm going to rewrite this as x equals -y minus 7. Why did I do that? Because I need one of the equations to be x equals or y is equal. So now I know what x equals. X equals -y minus 7. So I'm going to substitute that back for x. So I'm going to have 2 times -y minus 7 plus y is equal to -4. A little bit harder to solve, but I'm going to use distributive property. So -2y minus 14 plus y is equal to -4. -2y plus y, that gives me -1y minus 14 is equal to -4. I'm going to add 14 to both sides. So -1y is equal to 10. So y is equal to -10. So now I know what y is equal to, so I can just plug it into one of the original equations. It doesn't matter which one. So let's take the x plus y. So I've got x plus -10 is equal to -7. If I add 10 to both sides, x equals 3. And our answers are always ordered pairs. Let's try a problem off the practice for this week. Well, this one's fairly easy since I know what y is equal to. It's equal to x plus 1, so I'm going to substitute it right there. So I've got x plus 1 equals 7. So 2x plus 1 equals 7. 2x equals 6. X equals 3. Well, since the only problem up here that has a 3 for an x value has to be a, I'm going to just stop right now. Another practice problem. A little bit tougher because my y value is 2x minus 3, but I just plug it in here. I just put 2x minus 3 there. So I've got 4x equals 2 parentheses 2x minus 3 plus 6. Got to solve this, so I'm going to distribute first. That gives me 4x minus 6 plus 6. So those cross off. Uh-oh. 4x equals 4x. Now it's getting a little weird here. So that means any number I put in here is going to work. So if you think about it, if I put 5 in here, that would give me 20 equals 20. So I'm going to say that my answer is all an infinite number of solutions. Whatever equation, whatever function works for this one has to work for this one. It's the exact same equation. If you rewrite these, okay, so if you put the 2x over here and the y over here, and you know it's going to be the exact same thing. So it's going to have an infinite number of solutions. Now, if you ended up with that it wasn't true, okay, then you have no solution. So if you ended up with something like 2 is equal to 5, well, that's not true. You'd have no solutions. Now I'm thinking about this a little bit more. I'm not 100% sure I'm right. Because if let's say I divided through by x here. Yeah, that's right, because you'd end up with 4 is equal to 4, which is a true statement, so there has been an infinite number of solutions there.